everybody. We're on lesson number 6, page 133. We're doing sum and difference identities. In the last lesson of math 12. So that should make all of you happy. Okay, so don't worry about this table at the top. It's tied into lesson number 5. The bonus lesson, if you did that, you would have seen it before. Okay, so we have sine 60, sine 30. Sine of 60 plus 30, which we know is actually sine of 90. We want to show that it's equal to sine 60 cos 30 plus cos 60 sine 30. Now, I'm going to use in special triangles. If you skipped the bonus lesson, lesson number 5, you don't have to pay attention to any of this. You can fast forward till we get to the next page, this stuff. All right? But for those of you that did the bonus lesson, I'm going to rewrite this. So sine of 60. So if we do our special triangles for 30 and 60, 30 goes there, 60 goes there, that's 2, that's 1, that's root 3. Sine of 60, so sine opposite over hypotenuse is root 3 over 2. Cosine of 30, this one right here, which is root 3 over 2. Cosine of 60 is 1/2. And sine of 30 opposite over hypotenuse is 1/2. All right, root 3 times root 3 is 3. 2 times 2 is 4, so we have 3/4, plus half times a half is 1/4, which equals, they have a common denominator, so we get 4 over 4, which is 1. What's sine of 90? Well, if you think about the trig graph, that's the sine graph, that is 90, that value right there is 1. So we've shown that sine of 90, which is 60 plus 30, is equal to sine 60 cos 30 cos 60 sine 30. Now we could do it for the rest of these. If you want, you can go ahead and do that using the special triangle. But what you get is the sum and difference identities, and here they are right here. Sine A plus B is sine A plus B plus cos A sine B, blah, blah, blah. Go through them. They are on your formula sheet right here. Whoops. And these ones right here. Okay? Don't need to memorize them. Just need to know how to use them. I'm not going to go through this because there's addition identities and subtraction identities for tan as well. They've started one for you here. All right. They've taken tan A plus B. They split it up tan, which is sine A plus B over cos A plus B. And then they've used the addition identities of sine and cosine to get this bit. Then the non-intuitive part is they divide the numerator and the denominator by cos A, cos B. Because you're doing both, it's essentially 1, so it doesn't matter. But I'm going to leave you, if you want, to try and prove this next bit. This is an addition identity for tan. This is what you should get. And if you do the bottom one, this is what you should get. Again, both of those are on the formula sheet. All I care about is, can you use these? So we're not doing these two. Here it is right here. These two questions right here. So simplify the following. Sine 100 cos 10 minus cos 100 sine 10. So it's sine cos minus cos sine. Which formula does it look like? Sine cos minus cos sine. So that means it's equal to sine of angle A minus B. So I can rewrite this as sine, this is angle A, that's angle B. What did I say? A minus B? Yes, A minus B. A minus B. So it's sine of 100 minus 10, which is sine of 90, which if you can punch it in your calculator, or if you remember your sine graph, there's 90, that's 1. Sine of 90 is 1. That whole thing simplifies to 1. That's it. All right, next one. Cos. So this looks more complicated, but if you look, this and this are the same. So that's angle A. And quarter theta, a quarter pi plus theta, quarter pi plus theta. That's angle B. So we go cos A cos B minus sine A sine B. Cos A cos B minus sine A sine B. So that's equal to cos A plus B. So this will simplify to cos of A plus B, our A is 1/4 pi minus theta plus our B, which is 1/4 pi plus theta. Negative theta plus theta, those go away. A quarter pi and a quarter pi is 1/2 pi, or pi over 2. What is pi over 2? Hopefully you all screamed out 90. Really, they're saying, what is cos of 90? Just take a calculator, but if you remember the cosine graph, looks like that. That is 90. The cos of 90 is 0. And that's your answer. All right, so when it's big, long, and complicated, look to turn it into one of the addition identities here. All right, that's it. The only questions I would like you to do are numbers 1, 2, 8, and 10. All right, good luck. Let me know if you have any questions.